Hi guys, this is question 2 on the Unit 1 Summer 2019 Wjec past paper. And so we're asked to find all the values of k for which the equation x squared plus 2kx plus 9k equals minus 4x has two distinct real roots. Okay, so the first thing we're going to look at is this two distinct real roots. And that's a very important bit of information. So we have three scenarios with roots. So we have two real roots, and that we have two real roots when the discriminant is greater than 0. We have one real root when the discriminant equals 0, and we have 0 roots when the discriminant is less than 0. Okay, so I'm going to just draw these out graphically so I can show you where what that actually means. Okay, so we have a graph. So I'll draw the two real roots when d is greater than 0, when we have two real roots in blue, and that will look something like here. So we intersect the x-axis twice, so that's when d is greater than 0. Okay, we'll do one real root in red. And that's when it just touches the x-axis. So it's going to look something like this. So it just touches. And that's when we have d equals 0. And then our last scenario is when we have 0 roots. I'll do that in green. And that is when the line just doesn't go near the x-axis. So it doesn't intersect the x-axis. Great. So that's our first part, and we know that d is greater than 0, so that's the useful part here. So d is greater than 0. So what we need to now know is what the discriminant is, and if you don't know, the discriminant comes from the quadratic formula minus b plus minus root b squared minus 4ac over 2a. Okay, and the discriminant part here is this root. What's in this root? So this is the important part to us. So our discriminant equals b squared minus 4ac. And we know when we're using the quadratic formula that we have a quadratic equation, and we represent our quadratic equations in a x squared plus bx plus c equals 0. Okay, and we now have to change this equation we've got into this quadratic equation. So ax squared plus bx plus c equals 0. Okay, so I'll rewrite the equation we've been given. So x squared plus 2kx plus 9k equals minus 4x. Okay, so the first thing I'm going to do is I want 0 on the right hand side, so I'm just going to add 4x to both sides. So I'll have x squared plus 2kx plus 9k so plus 9k, plus 4x equals 0. Right, so now what I want to do is put a factorize. So because I've got x here and I've got an x here, I'll put them next to each other. So I'll have x squared plus 2kx plus 4x plus 9k equals 0. So all I've done is swap this 4x and this 9k, swap their positions, and it makes it easier for me to see like how I can factorize this 2k and this 4. So here we go, we got x squared plus, so here I'm gonna have 2k plus 4 x plus 9k. So all I've done is factorize that 2kx and plus 4x, and that equals 0. So now I've got it in in the way we like to write our quadratic equations. So now I've just got to use my b squared minus 4ac, and so I know this is going to be my a, this is going to be my b, this is going to be my c. So I'll write out the discriminant again. So b squared minus 4ac, and we want that when it is greater than 0. Okay, so let me just get rid of this d equals, okay. So this is what we got, so that's the discriminant when it's greater than 0. So here we go, so we got 2k plus 4 for our b, and that's all going to be squared. We have minus 4, so our a is just this 1 that's in front of the x squared, so our coefficient of x squared, which is 1. So 1, and then c is just going to be 9k. And we want that for greater than 0. Okay, so now let's simplify this. So let's expand this bracket, so we'll have 2k plus 4 and 2k plus 4. So that's going to be 4k squared plus 8k plus 8k plus 16. So simplifying that equals 4k squared plus 16k plus 16. So I can add that in. So I've got 4k squared plus 16k plus 16. And then we can multiply this out. So we've got minus 4 times 9k, so that's going to be minus 36k. We want that to be greater than 0. Okay, now let's simplify this. So what we can do is we can collect k's. So we've got 16k minus 36k. So we've got 4k squared minus 20k plus 16 is greater than 0. And now what I'm looking to do now is factorize these. But before I do, I can see that each coefficient is a factor of 4. I've got 1 times 4, I've got 5 times 4, and I've got 4 times 4. So I'm going to divide the whole equation by 4 first. So I'm going to have k squared minus 5k plus 4 greater than 0. Okay, so factorizing this, I'm going to have k, and then I'll have k here, and then I'll have plus little a plus little b. Okay, so I know my two equations for this quadratic to factorize. I know a times b equals 4, and I know a plus b equals minus 5. Okay, so to tackle this, I know because I've got a positive a times b, that's going to be a positive and a positive, or a negative and a negative. And because it's 4, I'm going to find the factors of 4, which are going to be 4 and 1 and 2 and 2. And so looking at this, I can use 4 and 1. So if I do minus 4 minus 1, then this, so minus 4 plus minus 1, that will give me minus 5. If I times them, if I do minus 4 times minus 1, that will give me positive 4. So that's, this second part satisfies the first green equation and the first part, the red equation. So I know factorizing these, I'll have k, so my a I said is minus 4, and I'll have k, which is minus 1. Okay, so I need to find values of k to get this greater than 0. So I know when k equals 4, it will when I put k is equal 4, this will then become, this bracket will be 0. If I put k as 4 in here, that whole thing will be 0, so my equation will be 0. But we're not looking for 0, we want greater than 0. Okay, and for this one, I know when I put k equals 1, I know it will be 0. I know that bracket will then become 0 and my whole equation will be 0. Okay, so I need to find if k needs to be greater or less than 4, or k needs to be greater or less than 1. So we can use this by using our quadratic equation. So we had k squared minus 5k plus 4 is greater than 0. So let's try. So we know if we put k equals 4, we're going to have 0, and if we put k equals 1. So let's try and do either side of 4. So if we do k equals 4.1, we're expecting 4.1 squared minus 5 lots of 4.1 plus 4. And we're hoping that would be greater than 0. So if you put that into a calculator, you get 4.1 squared minus 5 lots of 4.1 plus 4. Great, so we get that equals 0.31, which is greater than 0. So we're looking for when k is greater than 4. And then we can do the same for R1. So we know if we used k squared minus 5k plus 4 is greater than 0. So if we use k equals, let's try 1.1, we're going to have 1.1 squared minus 5 lots of 1.1 plus 4. And that, putting it into a calculator, you'll get, so here we've got a minus 0.29, which that is giving us less than 0. So we know we're on the wrong side of 1. So let's try k equals, well, this also proves that we're going to be looking for less than 1, but let's try it with k equals 0.9. Let's put an actual value that is less than 1. So we'll have 0.9 squared minus 5 lots of 0.9 plus 4. Let's see what we get there. So we get 0.9 squared minus 5 lots of 0.9 plus 4. So we get 0.31, which is greater than 0. Okay, so we now know that k needs to be less than 1, or k needs to be greater than 4, and we can write that together. So we can have k needs to be less than 1, or k needs to be greater than 4, and that's our solution. That's our ranges of k. Hi guys, if you found this video useful, please consider liking and subscribing. All written notes will be available in the description. Best of luck with all your exams, and I'll see you in the next one.